Hi, hello. Today I am going to explain about minimized DFA or minimization of DFA. We can minimize the DFA by using two methods. One is partitioning method, one more is equivalence method. Now I have to explain about the partitioning method. So before that, already you know about DFA. So how to minimize the DFA, the data flow diagram. So here DFA means minimized DFA means we can reduce the number of states of the given DFA. If two states are equivalent means then we have considered it as a single state. For example, here P and Q, these two states are equivalent means during transition for some input, it may be A or B or 0 or 1, anything from state P to final statements, then Q also it goes to the final state for the same input during transition. Suppose during transition P goes to non-final statements, then Q also doesn't goes to the non-final state. So this is nothing but the equivalent condition. If both states are equal, either it goes to the final state or it goes to the non-final state. So this is the given question. So here there are 8 states are there. How we can minimize this 8 state into some other states. So we will see the steps now. So first in equivalence 0, this is pi naught is nothing but the equivalence 0. Here we are going to find out which states are equal. In the first step, we are considering or creating the group final state as one group and non-final state as one more group. Here final state is only C. Non-final states are remaining states. So A, B, D, F, G, H. These are all non-final states and C is the final state. These non-final states we name it as group 1 and in final state we can name it as group 2. So there are two groups in the zero equivalence for all problem. One is a non-final state and one more is final state here. Now we can consider or draw the table. How we can draw the table means the rows it contains the input. Here the input are 0 and 1 and the columns it contains the states. There are 8 states. Here we can mention all the 8 states here. So during transition for the state A input 0, state A input 0, it goes to the state B. B is in the group 1. So here we can mention the group number. It goes to the state. For state A, the input is 0. It goes to the state B. B is in group 1. Similarly, for state A, for the input 1, it goes to the state F. F is again it is in 1 here. So here we mention it as 1. Similarly, for the next state. For state B, input 0, it goes to state G. G is in group 1. So here we can mention it as 1. For state B, for the input 1, it goes to the state C. C is the final state that is in group 2. So here for state B, for the input 1, it is 2 here. For state C, input 1, it is the self loop. So here I made a mistake. For state C, no, it's correct only. For state C, here the input is 0. For state C, the input 0, it goes to the state A. A is in group 1. So here we can mention it as group 1 here. And for state C, for the input 1, it is the self loop. So C is in group 2. So here it is 2. Similarly, for state D. For state D, the input 0, it goes to state C. It is in group 2. So D, input 0, state C. So here it is 2. And for input 1, it goes to G. It is in group 1. So here it is 1 here. For E, the input 0, it goes to H. H is in group 1. So here it is 1. For E, the input 1, it goes to state F. F is again it is in 1, so 1 here. And for F, input 0, it goes to state C. State C is 2, so 2 here. And for state F, input 1, it goes to state G. G is in group 1, so here group 1. And for G state, input 0, it is the self loop. So it is in 1 only, so 1. And for input 1, it goes to E. E is again in 1, so here it is 1 here. For H, the input 0, it goes to G. G is in group 1, so 1 here. For H, for input 1, it goes to state C. So state C is in group 2, so here it is 2. So in this way, we can draw this table. From this table, we can write the equivalent state. So how we can write the equivalent state means, for the state A 0 and 1, it goes to the state 1 and it goes to the group 1 itself. Similarly, we can consider the remaining states. So here for state A, then here it is 1 1. Similarly, we can check for the other state. Here it is 1 2. It is not equivalent. So here also it is 1 2. Here also 2 1. But in E it is 1 1. For the input 0 and 1, it goes to the same group 1 1. So we can write that state here. And similarly for G, it is 1 1. So we can combine these three state into a single group. The already I told this minimization of DFA is done by using partitioning method. Here for C, there is only one state. Here it is not possible to partition anything, but in one there are 7 states are there. How we can partition these 7 states? So here we can check the input for each and every state. If it is same for A 0 and 1, it is 1 1 means we can check the similar transition for remaining states means we can consider that as a single group. So for A, E and G, it is 1 1. We can make it as a single group. And for B, the input for 0 it is 1 2, C also 1 2, and H also 1 2. But C is a final state, so we can it is not possible to join with this group. We can write the C as a separate state here, and B and H as a equivalent state. So we can write B and H as a equivalent state. We can combine that two states here. Next, for D and F, it is 2 and 1. So we can combine these two states D and F. In the zero equivalence, there are only two groups, final and non-final state. This is final state and these are all non-final state. Now in the equivalence one, we can partition that into three groups. Group 1 is partitioned into three groups here. Here there is no change in the final state, so we can use the same group number 2 here. But these are all partitioned from group 1. We can rename it. After 2, it is 3, 4 and 5. Now repeat the same step. Draw the table. The rows contain the input 0 and 1. Here columns contains the state. Now check the transition for the input 0 for the state A. From state A, 0 input, it goes to B. So B, now we can check B is in which group? B is in fourth group. So here we can mention it as 4. Now for A, input 1, it goes to F. F is in fifth group. So here we can mention it as 5. For input B, sorry, for state B, the input 0, it goes to G, and 1, it goes to C. C, there is no change. So for input 1, it is to 0, it goes to G. 0, it goes to G. G is in third group. And the input 1, it goes to the final state 2. So that is C. It is in group 2. Similarly, for state C, we have to check for the input 0 and 1. For C, 0, it goes to A. 1, it is the self loop. So 0, it goes to A. A is in the third group. And the self loop is C. So C is in second group 2. Next state is D. For D, input 0 and 1. 0 it goes to state C, and for 1 it goes to G here. C and G. So C it is in second group and 1 it is in group number 3. G it is in group number 3. So here it is 2, 3. For E, input 0 and 1. For E state, input 0 and 1. 0 goes to H and 1 goes to F. H and F. H and F. H is in state 4, F is in state 5. So here it is 4, 5. And for F, 0 and 1. 0 C, 1 G. C and G. C it is in group 2 and G it is in, sorry, here. C it is in group 2, G is in 3 here. For state F, 2, 3. For state G, 0 self loop, that is G. 1 E, G and E, G and E. G is in 3, so for G it is 3. A is also in 3, so here it is 3, 3. Next, for H0 input it goes to G and 1 it is C. G, C, G, C. G is in 3 and C is in 2, 3, 2. So this is the table now. Now again we can combine the state or find the equivalence for this table. So this is the second equivalence. We can write it as pi 2. Here for state A, input 0 and 1, it goes to the group 4 and 5. So we have to check the similar group for remaining states. So here 4, 5. Here for state E, again it is 4, 5. We can combine these two as a single group A, E. For the remaining it is different. So we can combine the group or combine the state as a group for state A and E. Next 3, 2. 3, 2 is BC and then H. Again C is in non-final state, so it is not possible to separate. We can combine B and H as the single group, C is the separate group. Next one is 2, 3. 2, 3 is D and F. So D and F combined as a single group. 3, 3. G is a separate group here. For 3 and 3. For G, the input 0 goes to group 3 and for 1 also it goes to state 3. But it does not similar to any other state. So we can write the G as a separate state here. Now again we have to rename the group. BH, there is no change, so we can use the same number. DF also there is no change, we can write the same number. C, it is a separate group, that is final state, so there is no change, we can write the same number, group number here. But AEG is partitioned into two groups, so after 5 we can mention it as a sixth state and a sixth group. For G it is the seventh group. So again we have to draw the table for this partition, this equivalence. Input 0 and 1 in the row and states A, B, C, D, E, F, G, H are there. So here for the input A, similarly we have to check the transition diagram. For input A, 0 and 1, B and F, B and F. B is in fourth group, F is in fifth group, 4, 5. Next for B, for state B, input 0, it is G and 1 it is C. G and C. G and C. G is in seventh group and C is in second group, 7, 2. Now for state C, input 0, it is A and for 1 it is a self loop, A and C. A and C. A is in sixth group and C is in second group. For state D, 0 it goes to C and 1 it goes to G. C and G. C is in second group and G is in 7th group for state D. For E 0 goes to H, 1 goes to F, H and F, H and F. H is 4, F is 5, so 4, 5. And for F state 0 goes to C and 1 goes to G. C and G. F, C and G. C is 2, G is 7. 2 and 7 for F. For G, 0 goes to itself, self loop, and 1 goes to E. G and E. G and E. G is 7, E is 6. 7 and 6. For H, 0 goes to G, 1 goes to C. So here 0 goes to G, G and C for H. G and C. G is 7 and C is 2. So now this is the table. Again we have to combine the equivalent state, that is equivalence 3. Here for state A 0 and 1 it goes to the group 4 and 5. 4 and 5 here. E it also goes to 4 and 5 for the input 0 and 1. We can combine this as a single group A and E. And for B 7 2 again H it is 7 2. So we can combine these two as a same group. And D and F, D it goes to 2 7 and F it also goes to 2 7. So we can combine this as a separate group. C it is a final state, we can write it as a separate group. And G again it is not similar to anyone, so we can write this as a separate group. Now we can compare pi 2 and pi 3, that is equivalence 2 and equivalence 3. Both are same. Here also it is AE, G, G, BH, BH, DF, DF, CC. There is no partitioning on equivalence 2. So here pi 3 is equivalent to pi 2. That is pi 3 is similar to pi 2. Hereafter there is no partitioning occur. This is the final step for partitioning. Now we consider AE as a single state, G as a one state, BH as a single state, DF as a one state, and C is a one more state. Here in the given question, there are 8 states are there. After minimization by using partitioning method, it is converted into 5 states here. AE, BH, DF, G and C. A is the initial state in the given question. So here also A is there. So it is the initial state. For the input 0, it goes to the state B, and for input 1, it goes to the state F. Sorry. For A, yes. For A, input 0, it goes to state B, and for 1, it goes to the state F. Suppose if we check for E, it also goes to either B or H for input 0, and for 1, it goes to the state D or F. So here we can check for E state. For E, the input 0 it goes to H and input 1 it goes to F. Input 0 it goes to H and input 1 it goes to F. So these two are considered as a single state. So that's the reason in the beginning itself I told, for the if two states are equivalent means for the same input it goes to either final state or non-final state. Here for the same input 0, both state A and E it goes to the non-final state. It is available in a considered as a single state here BH. Now for B and H, for input 0 for state B. So for state B input 0 G and 1 it is C. So these two are two separate states. For state B 0 it goes to G and 1 it goes to C here. B is over. And for C, input 0 it goes to A, 1 is a self loop, 1 is the self loop, and C it goes to A here. And for D, D it goes to, for input 0 it is C and 1 it is G. For D state is here. For input 0 it is C and for input 1 it is G. Next, for E, input 0, it goes to H. For E, already it is in here. Already we drawn it for A. It is equivalent, so no need to draw it again. It is already, there is a transition here for E for the input 0. And for input 1, F is also there from state A, so it is similar for E2. Next one is F. For F, already we draw it for D state, so it is same here. For F, 0 it goes to C, and 1 it goes to G. So 0 it is C and 1 it is G. And for G state, G for the input 0, it is the self loop. So self loop here. And for 1, it is E. G to E is the, for the input 1, it goes to the state E here. And for H, 0 goes to G, 1 goes to C. H, 0 goes to G, 1 goes to C. Already we can draw this transition for state B. So there is no need to draw it again. So in the given question, there are 8 states. After minimization using partitioning method, there are only 5 states. These 2 states are considered as a single state in the minimized DFA. Thank you.